Good morning. Today we are going to be graphing our absolute value functions. We're going to start off first with our parent function, and then we're going to look at some transformed functions and talk about how the key features change for each of those transformations. So, as I said, we're going to start off with just our normal parent function, absolute value of x, and to determine where I'm going to graph this, I'm going to put some values in my xy table and find my outputs and then plot those on my graph. So the absolute value of -2 is +2, the absolute value of -1, +1, absolute value of 0 is 0, absolute value of 1 is 1, and the absolute value of 2 is 2. So here are my 5 points that I'm going to plot. Oops. And there is my parent function. Now, what is the domain of this function? My domain is all real numbers. My range is all numbers greater than or equal to 0. I have an x-intercept at 0, 0. Same for my y-intercept. I'm increasing walking uphill from 0 to +infinity. And I'm decreasing walking downhill from -infinity to 0. And this isn't on here, but I do want to go ahead and talk about where my vertex is, and for the parent function, it is at 0, 0. So that is our starting point for the rest of these graphs. Looking at my next one, absolute value of x -3. Now what I could do is go through my xy table, find some new points, and plot those, or I can recognize that this means a vertical shift down, shift down 3. Now a vertical shift affects my y coordinates, so what I'm going to do is take these points from my parent function, my x values won't change, and I'm going to subtract 3 from each of my y's. This will be -1, -2, 0, -2, -1. Oops, and that's not 0, that's -3. Silly Miss Treadway. Brain fart. So those are going to be my new coordinates. Now, how can I make sure I did this correctly, that I identified the correct transformation, changed the correct coordinate? Well, you could pick any of these x values and plug it into the function to see if you get the correct output. Let's pick one at random. Let's do -2. The absolute value of -2 is 2. 2 minus 3 is -1. And you could do that with all of your points to make sure that you have found the correct coordinates. So I'm going to plot my new points for my transformed function. My domain is still all real numbers. My range, however, now is all values greater than or equal to -3. My x-intercepts have shifted. I now have 2, one at -3, 0, and the other one at 3, 0. My y-intercept is at 0, -3. I'm still increasing from 0 to +infinity and decreasing from -infinity to 0. And my vertex is now at 0, -3. On to my next graph. I've got the absolute value of x -2. Again, I can recognize that that -2 on the inside is going to be a horizontal shift. And because it's subtraction, that means I'm moving to the right 2. So for a horizontal shift, that changes my x coordinates. So referring back to that xy table we had for our very first function, I'm going to keep all my y values the same, and I'm going to add 2 to each of my x coordinates. So all those y's are going to stay the same. And I'm adding 2 to each x. And again, how can I check to make sure I have done this correctly? Pick any value. Let's go with 4. Plug it into my function. 4 minus 2 is 2. The absolute value of 2 is, in fact, 2. And you can do that for all 5 coordinates to make sure you have correctly identified them. Here's my new graph. My domain is still all real numbers. My range is still all values greater than or equal to 0. My x-intercept is now at 2, 0. My y-intercept is at 0, 2. Now I'm increasing from 2 to positive infinity and decreasing from negative infinity to 2. And my vertex has shifted to 0. All right, we've got 2 more on the back. What I'm going to put right here is my first XY table for our parent function, so we can refer to that when we're making our new one without having to flip back and forth constantly. Ooh, that's an ugly 2. Let me fix that. Okay. That one's a little bit prettier, still not great. All right, on this 4th graph, I've got a couple transformations happening here, and this marker just does not like me today, so we are gonna write it with something else. There we go. That's a better looking 2. Okay, I have 2 things happening here. I have this negative on the outside tells me I'm reflecting over the x-axis. And then that +1 on the inside tells me that I have a horizontal shift to the left 1. So thinking about those 2 transformations, the reflection changes the y-coordinates and it changes the sign of each of these. So for each of my y-coordinates, that's going to become -2, -1, 0 stays 0, -1, -2. Then going to the left one, that affects my x-coordinates, and I'm going to subtract 1 from each of these. And again, I can pick one of these at random, plug it into my function, make sure I get the correct output. Let's go with -1. The absolute value of -1 + 1, -1 + 1 is 0, so that gives me 0. We could try another one just to make sure we've got it correct. Let's do -3. -3 + 1 is -2. The absolute value of that is 2, but then the negative on the outside gives our output as a negative. So let's plot these new points. And here is my transformed function. My domain is still all real numbers, but my range is now all of the negatives. So it's those values less than or equal to 0. My x-intercept is at -1, 0. My y-intercept is at 0, -1. Now I'm increasing from negative infinity to -1, and I'm decreasing from -1 to infinity because of that reflection. It swapped my graph upside down. And my vertex is now at -1, 0. Okay, last but not least, once again I have 2 transformations. That 3 on the outside is going to be a vertical stretch times 3. And then that +3 on the inside is going to be a horizontal shift to the left 3. So that vertical stretch is going to change my y coordinates, and so I'm going to take each of my y's and multiply them by 3. So that will give me 6, 3, 0, 3, 6. And then the shift to the left, I'm going to subtract 3 from each of my x coordinates. So that will give me -5, -4, -3, -2, -1. And so now I get to graph each of those points. Again, you could plug any of these back in and make sure we did it correctly. So -5, 6, -4, 3, and here is my transformed function. Domain is still all real numbers. My range, all values greater than or equal to 0. My x-intercept is at -3, 0. My y-intercept I don't see on the graph, so how can I find it? Well, remember, your x-intercept is when x is equal to 0. If I plug in 0 here for x, 0 plus 3 is 3. 3 times 3 is 9, so that's going to be at 0, 9. I just can't see it on my graph. I am increasing from -3 to positive infinity, decreasing from negative infinity to positive 3, and my vertex is at negative 3, 0. Now let's talk about what each of these transformations changed. Which transformations changed the range of the graph? So looking at our parent function, my range was y is greater than or equal to 0. Well, where did that change? It changed here when I had a vertical shift down. It also changed here when I reflected over the x-axis. So transformations that will change your range are vertical shifts, and reflections over the x-axis. And this is for our absolute value function. And then what transformations change the domain? My domain for all 5 of these functions that we graphed was all real numbers. So for our absolute value functions, there were none. None of these transformations affect the domain for our absolute value parent function.